All right, let's talk about something that's absolutely fundamental to Java programming, how it organizes data. If you've ever needed to store and manage a group of items in your code, then you're in exactly the right place.
Okay, so here's a question for you. What does a shopping list have in common with your social media feed? It sounds a little random, I know, but think about it. They're both just collections of items. And in programming, just like in real life, you have to use the right container for the right job. And that's exactly where the Java Collections framework comes in. It's like this amazing toolkit of containers, each one built for a very specific task. So at its core, what this framework really gives us is a standard set of tools. We're talking about interfaces like list and set, a bunch of different ways to implement them, and some really powerful algorithms to handle groups of objects super efficiently. This stuff is the bedrock for so much of what we do in Java, so let's jump right in with the most common type.
First up, we've got lists. And honestly, the best way to think about these really is a shopping list. They are perfect for those times when the sequence of your items is absolutely critical, when you have to know what comes first, what's second, what's third, and so on. The two key words you have to remember here are ordered and duplicates allowed. It means you can add milk to your shopping list twice, and guess what? It'll show up twice, in the exact spot you added it. This kind of predictable, sequential behavior is just essential for tons of things, from tracking user actions to laying out the steps in a workflow. And this is where you have to make a really key decision. It's a classic trade-off. You're going to want to choose an array list when you're mostly just reading items by their position. Since it's backed by an array, it's like a numbered shelf. You can just instantly grab item number 5. But if you find yourself constantly adding or removing items, especially from the beginning or the end, LinkedList is way more efficient. It's built more like a chain, so you can just add or remove links without having to shift the whole thing around.
Okay, so let's switch gears and talk about sets. What if you only want to store unique items? I want you to picture a key ring, right? You wouldn't have two identical keys for the same door. Well, that's the whole idea here.
Yeah, this is the main principle of a set. Uniqueness is guaranteed. If you try to add something that's already in there, the operation just gets ignored, no error, no fuss, nothing. This makes it perfect for tracking things that have to be unique, like user IDs in a system, or say, all the distinct words in a big document.
And you guessed it, just like with lists, your choice of set really matters. If you just need pure speed and you could not care less about the order, HashSet is your go-to. If you actually need to remember the order that items were added, well, LinkedHashSet preserves that for you. And if you need your unique items to always be sorted, TreeSet takes care of that automatically. Pretty cool, right?
All right, time for our third major container type, maps. Now these work a little differently. Instead of storing single items, they store pairs of items, basically linking one thing to another.
The most important part of a map is the key, and that key has to be unique. This key value structure is just incredibly powerful. Instead of digging through a whole list to find what you're looking for, you just ask the map, hey, what's the value for this specific key? And you get an answer back almost instantly.
And once again, we've got choices based on what we need. HashMap is the fast, all-around default choice. LinkedHashMap is awesome for things like caches, where the insertion order is important. TreeMap keeps all your keys sorted for you. And this last one is really important. If you have multiple things or threads trying to access your map at the same time, ConcurrentHashMap is designed to be thread-safe, which prevents your data from getting corrupted and keeps things stable.
Okay, so we've got our core containers, lists, sets, and maps. Now let's look at some of the really powerful tools the framework gives us to work with these collections. Think of these as the power-ups.
Generics. I mean, these were an absolute game changer for safety. Before generics, a list was just a list. You could accidentally stick a number into your list of names. Generics let you create a specific mold for your container. So by declaring a list of string, you're telling the compiler, hey, this container holds only strings. If you try to add an integer, you get an error right away, long before your code ever runs. It's all about catching those mistakes early. So you might be wondering, how do sorted collections like TreeSet actually know how to sort things? Well, we have two main tools for that. First, there's Comparable. This is for when an object has a single natural order. You know, like how numbers or words naturally sort themselves. The object itself knows how to compare itself to others. But what if you need different ways to sort the same thing? That's where Comparator comes in. It's like an external rule maker. You can have one comparator to sort contacts by last name and a totally different one to sort them by city. It gives you incredible flexibility. And then we've got the Stream API, which is this really modern and powerful way to process collections. I want you to think of it like a data assembly line.
You start with a source collection, you push it through a series of operations, maybe filtering out items or transforming them, and then you collect the final result at the end. Instead of writing all these loops to manage every little step, you just declare what you want to do. It makes your code so much more readable and expressive.
Okay, so we've looked at all these different containers and tools. It might feel like a lot of options, but why is it so incredibly important to pick the right one for the job?
This right here is the bottom line. Choosing the wrong tool for the job isn't some small mistake. Using a linked list when you need to frequently access elements by their index, well, it's like trying to find a specific book in a library where none of the shelves are labeled. It's going to be painfully slow. These choices have real, tangible consequences on your application's speed, its memory usage, and its overall reliability.
So to make it super simple, here's a quick little cheat sheet for you. If you need a sequence of things in a specific order, just use a list. If you need to guarantee there are 0 duplicates and speed is what you're after, use a set like HashSet. And if you need to look things up really fast using some kind of unique ID, a map is your best friend. Oh, and if you want your items to stay automatically sorted, TreeSet or TreeMap have got you covered.
Ultimately, the Java Collections Framework, it isn't just a library. It's a powerful, precise toolkit for bringing order to data chaos. The tools are right there for us to use. So the final question really isn't about the framework. It's about us as developers. How are we going to choose the right tool to build cleaner, more efficient, and more reliable software?